right. Um, Welcome to a special Sunday edition of Common Lisp Study Group. I'm your host, Ron Baden with Atlanta Functional Programming. Today, we'll be continuing our fourth interpreter, following the example and case study that's mentioned in Let Over Lambda, Chapter 8. And a couple of things that I want to do before we begin our actual live coding session. Wanted to mention a few things that we did last time. Just probably do a little bit of cleanup before we begin, and hopefully we could get pretty far today. First things first, as you may have recalled, last episode yesterday, we went and defined our abstract registers. These abstract registers are a representation of a fourth. It's a portable representation of an abstract machine that we are implementing our fourth to. This consists of two stacks, a parameter stack, which holds the parameters that we're pushing onto before an operation is actually, or word is actually activated on. The return stack, which is the code that will actually execute on the parameters. So when we visit a particular word, we then pop off the appropriate number of parameters for that given function call, run the function, and then return the results if there is any back onto the parameter stack. Additionally, this has a program counter, of course, to keep track of what code or word we're actually executing. Dictionary of words that we would be dealing with in terms of words available in our vocabulary. Those are instructions you could see that are equivalent to operations in code that can be executed on the fourth interpreter. Then finally, two additional variables, compiling and dtable, that we haven't actually touched base on, but they're related to how the code is actually going to be compiled. A couple of things yesterday that did not, I felt afterwards, that did not get really clearly explained, that I'm going to touch base here a bit here because it's going to affect how we're going to be doing today's work, is this notion of threading. The book itself, if you read it, defines technically four different ways of compiling fourth code. There is the so-called indirect or direct threaded code, which is related to how fourth is structured to actually compile to an underlying processor. It will actually keep track of adjacent memory cells that are pointing to particular instructions or particular words, and it will call those instructions or words directly in this directed or indirect threaded code mode. Then there is two higher level threading modes. One is called token threading mode, which is given how a word is laid out in memory, or a set of instructions are laid out in memory for a piece of code for fourth, each pointer to the word within the same compilation block, you will, which is fourth called the thread, is actually associated, a word in that block would be associated with a pointer, which is represented by a fixnum, and you would then access that pointer through the fixnum and execute whatever word is represented in that actual fixnum pointer that's available to you. That's what token threading is. So you can see that allows you to jump around within a particular code block to execute particular instructions. Another threading mode that's available in fourth, although a lot of fourth users, for resource constraining reasons, tend to pick one of the three prior ones, is subroutine threaded code. Now, subroutine threaded code is nothing more than what most modern compilers use to actually go and at the instruction set level, at the assembler level, jump to particular subroutines. So you would know ahead of time the address in memory where a particular subroutine starts, and you would then branch or jump to that particular subroutine when a function call is invoked. Of course, in modern languages, you'd also have to do all the setup in order to invoke the function. Since Forth doesn't have those stack manipulations because they're kind of exposed to you directly, you have more control over how to invoke the function, whereas in most compilers for modern languages, they hide that from you. They end up creating a particular data structure called stack frame that would hold the information to return back to the previous state before it invokes a particular function call. Now, what we're implementing in this Forth implementation today is actually a fifth actual way of doing Forth's threading model, and that's very specific to Lisp. We're actually going to be leveraging the console structure and Lisp's dynamic typing to actually go and figure out what the next execution form, and the book conveniently calls this const-threaded code. So when we talk about const-threaded code, that's very specific to the Forth threaded code that we're implementing as part of the case study. Another thing that I want to just clarify is the inner interpreter. Now, the inner interpreter, as it stands today, this is a very simple interpreter that we were talking about that we're going to be leveraging. In today's episode, we're not going to really be touching based on the inner interpreter just quite yet, mainly because a lot of our examples are going to be dealing with the bootstrapping environment. I just wanted to mention that to folks, so if folks are just tuning in and wanting to understand, well, what about this inner interpreter we talked about yesterday? Why isn't that even in our code? That's because we're not going to be touching base on that just yet. We need to actually finish off the basic bootstrapped runtime environment in order to get our Fort off the ground, and then we will start dealing with the inner interpreter. So just make sure that I'm on talk here. Yes. Okay. So we talked about abstract registers and abstract routines and threaded code. And we've implemented our lookup utility for words, as you saw in Forth lookup. How do you put that? Here. Forth lookup. Yeah. And this function just takes in a dictionary where the top word is the first word that we're looking into, and we recursively go through the list until we hit the head of the actual list. Well, the tail in this case. And if we found the word that we're looking for, we return it. Otherwise, we don't. One thing to note about this, and I'm sure most people have probably at least looked at it and wasn't thinking twice about it, but yesterday I noticed the EQL versus EQ or equal. As it turns out, Forth allows you to have special operators and numbers as part of a particular operation. So obviously you can't use EQ at that point. You're going to have to either use EQL, but you can't use equal because equal is going to look at two constants and their values. So when you're doing searches, more than likely the equal operator that you're going to be using is EQL, not equal for anything related to looking up a particular dictionary word. But at this point, though, we're not entirely just ready to actually start executing this Forth inner interpreter. We have our registers defined, we have our basic operations defined, which you could consider as behaviors, but we haven't actually stitched them together. since we're in Lisp, the most natural way of implementing this, well, we have registers, which is state, and we have behaviors. So you should be thinking, you know, oh, this can be closed by using let over lambda. So that's exactly what we're going to be doing. We're going to be implementing a fourth interpreter that basically, or sketching out, more importantly, a fourth interpreter that will load our words, our operations into some sort of dictionary, and then start using them. So how does this kind of look like? Well, the easiest way of doing this is using just a macro. Let me just go ahead and print this, write this down. Sketch a fourth interpreter that will load up initial dictionary and start looking through. So we could just go ahead and create a new fourth interpreter. Now I'm calling it like this because just because the book calls it new fourth. Didn't sound like, I was like, what do you mean by new fourth? Wasn't very clear that means you're creating an instance of an interpreter every time you're actually instantiating it. So I just went ahead and called it like this. This guy, all it does is it takes our fourth registers that we defined. It will first install the primitives. We haven't defined this just yet. This will happen in later on today's discussion. But what it does is you could think of it as setting up the initial dictionary. And we will do a couple of other things related to that later on. Then, of course, you know, we'll return a lambda because this is, you know, obviously let over lambda, where we are creating a closure on here that takes in the next word, so you could pass code into it. We check to see in our fourth lookup whether or not this value that we passed in is in our dictionary. And if it is, we will pass this into a function that will take that code and execute it. Otherwise, we will, you know, handle it, saying we'll write some error handler that will actually go in and handle that particular word. So that's our fourth interpreter. You can see it's not much. It's a closure that takes in a value, but it's a very powerful closure because what it's doing is it's setting up our dictionary. It is setting up the primitives, and it is just giving us a function, a brand new function with that new environment. This setup allows you to take, say, you know, this won't necessarily work right now, but if we want to create a new fourth interpreter, we could just, you know, specify a variable called new fourth. Of course, you know, I'm not going to follow the thing for sake of we're going to follow some standards here. We're going to earmuff our global variable, our variable, and we'll just go ahead and then, you know, instantiate this guy. So while I've compiled this, I can't actually, you know, execute it just yet because we haven't actually defined fourth installed primitives or fourth handled or fourth not found. These are going to be macros that are going to be setting up our initial code, and we'll do that in just a little bit. But there's a couple of things here that we need to first think about when we look at this code, this new fourth interpreter. Let's take a look at the sketch for a minute. We're sketching a basic outline where we're setting up a fourth environment, and we're grabbing code, and we can invoke the fourth environment on each argument sequentially. But there's that's not necessarily a good approach, because ideally you want the environment to be set up only once, right? You don't want it to be set up every time. Instead, what you may want to do is you evaluate the fourth environment once, and then pass in whatever values or words that you're passing into the fourth environment. If this doesn't sound like a use for once only to folks, I'm going to be touching briefly on that and giving us a review. So what do I mean by once only? As you may have recalled in our Let Over Lambda series earlier, in our macro generation series, we've talked about once only in the past. Once only, what it does is it evaluates an environment once, and it gets passed in a particular form once, and makes sure that the results at compile time are actually referenced in the appropriate places. A good example of this is if you want to write a square macro, right? You could call once only. I'm not gonna. I'll defer to our earlier episodes on once only to look at the actual implementation of the code. I'm going to be using Alexandria's once only for the sake of our example here. We will, evaluate whatever's passed into square once, and then we go ahead and implement our macro of generating the results, right? And what is that? Oh, dang it. Hold on a second. Did I forget to... Yeah, I did. I apologize. Forgot to put local nicknames in here. Okay. There we go. Now, when we try to expand, let's say, 1 plus 2, if we expand this guy, you will see that what happens behind the scenes is we generated a symbol and had the result of 1 plus 2 stored in that symbol, and then referenced the result into the code. So that's what once only does. Well, what we're going to do here is we're going to actually use once only to define a macro called go forth that takes our fourth environment and the rest of the words that are passed in. My apologies, this should be body. For folks who are referencing the book, just a safe reminder, the book constantly uses ampersand rest for the rest of the arguments, for the rest of the code and macros, and while that is acceptable to the Lisp environment, it's not good style. There is an at body. If you're going to be writing macros, use the ampersand body to represent body of the body of a macro instead of rest. So what this fourth environment, a go forth environment, apologies, OBS just disconnected for some reason. All right. So what this is going to be doing is this is going to take our fourth environment, once only fourth. Okay, now we've actually set up our fourth environment. We can now go through each of the lists of the fourth, each of the lists of the words, one at a time. Do list words. And we will fun call our fourth on the word. Now, oops, sorry, not fourth, comma fourth. I need to splice that guy. There we go, much better. Now, if you look at this and
okay, question.
Yeah, sure.
Okay. In the book, they have def macro ampersand. Sorry, exclamation.
Mm-hmm.
Before the fourth, the first parameter, they have unbound.
Right.
So I guess that's the once only.
Richie, that you're beating me to it. I was just going to review that. So for folks who are looking in the book, Hoyt actually goes through and created a new syntax for doing once only called def macro bang, and it uses O fourth, and he separated O bang symbols from G bang symbols from globals and what's being passed into the environment, and he generates a new symbol internally through that, and that entire operation of converting the O to a global G in the book is handled by once only. That all that code that he wrote is essentially an implementation of once only.
Okay.
I can bring up the once only macro to show you what this does. But if you go back to chapter 3, in where he talks about the O bang and G bang symbols, unwanted capture, and he defines that def macro bang, he talks about it only being a once only environment, and it's going to be once only evaluation. But he doesn't actually leverage, like, he wrote his own implementations of it because he didn't feel like the implementations that he saw of once only were complete or something like that, and he ended up writing his own. And just to go through it to show you how you can create these macros that generated symbols and maintains variable capture. Later on, we're going to be talking about anaphoric macros because we're going to be using anaphoric macros for this fourth interpreter, and that still in his book goes through like a lot of like once only semantics. So there, I've also used once only. Other questions?
That's it for me.
Okay. All right. So this is all well and good. This actually prevents us. We don't even necessarily. Originally, we didn't even have to actually do this go forth macro. What exactly does this go forth macro really solve? Well, what it does is when you have this original interpreter and everything's actually set up and implemented, you could have easily executed your code. This is going to be verbose. It's going to be very clumsy, very bug-ridden. But you could totally write your code clumsy way. I'll call it the clumsy way of using our fourth interpreter before pre-go forth. Okay. You can create a prog-end, and once you have that new fourth, you can just call it on every parameter. So let's say that we wanted to do fourth code execution. Let's take the book, the example that they had in the book. We duplicate 3, we multiply it, and then print it, which is essentially squaring the number 3 and printing it. All right. You could call 3, push it onto the stack. You could call new fourth on the symbol dupe, and then obviously you could go all the way down till print. So let me just do this, and then star, and then new fourth print. And this would actually technically work, okay? It's ugly, but it will actually work because it will set up the environment, it'll load it onto the stack, and since it's a closure, it will keep track of what's available. But as you could probably tell, this is not an efficient way, nor is it a maintainable way of writing forth code in Lisp. All right. So go forth allows you now to essentially do just right. Go forth. Do forth. 3 dupe star print. Doesn't that look much cleaner? That is, and we're just getting started. But you could see immediately that this is a very useful macro. But we're not just done yet. Obviously, we were talking about this bootstrapping code, and we have all these operations, these primitive operations. They're not loaded into any specific dictionary just yet. So we need to have some sort of standard library, like that's referenced inside the forth environment. Since forth has a mixture of both symbols and some atoms, some constants later on that we're going to be discussing, you could actually implement the standard library just like what we're doing before and actually use store it as a list. And that's what we'll do just now. We'll define a variable, a new variable, representing our standard library, like it was mentioned in the book. And again, I'm going to be using some standard common Lisp, some practices here. I'm going to define this as a global, a def var, and with the earmuffs and stuff. And then I'm going to define a macro. We're going to define a macro called forth standard library add. And this is going to allow us to essentially set up the standard library with a list of symbols that we want it to be part of. So we're going to go ahead and create the standard library add. That's going to take in what is it? That is going to take in all of our arguments one at a time. 1 second. Okay, I don't really care about that. Sorry, for some reason, Hangouts and the stream is giving me like the occasional error messages if you guys can't see. Somewhat a little inconvenient for me. Okay, so where was I? I will take all the arguments and do a set f on our standard library argue. And we do an income on this standard library, and all it is it's grabbing all this code, concatenating it with it, and then storing it. So we have this, we have this. Now what are we going to do? Now we can actually just set up our standard library and then use it. To load this, though, you may want to leverage something specific like an anaphoric macro. Why? Because you want the actual fourth closure to be wrapped around this specific instance of the standard library. So if you recall how let works, and we can go and actually take a look at the let macro. I will, for sake of convenience, copy this code from one of my earlier scripts into our current buffer. This macro, what this does is it executes the last body first, and then it will execute then all the preceding arguments before it, and it will return essentially applying the function that we've evaluated before, that's wrapped by the disk pointer here, as you can see right here, and it will apply to the rest of the parameters. This is actually useful because what it's going to do is it's going to change our fourth interpreter to essentially keep track of the state of the current environment that it was instantiated with, and no other, and those bindings are available internally to the rest of the function using the anaphoric this that's there. So let's see how this is going to change our existing code. What I'm going to do is I'm going to split my window so you can see the old version and the new version at the same time. So let's go back to our fourth here. This is our fourth interpreter, if you recall, our new one that we just defined. It's going to go ahead and copy this and paste it here. And all we're doing is first, we're going to just take this let, make it an alet. That's all we're doing. That now gives us access to the this anaphora that we'll then use to essentially add new words into this this library. Then what we'll do is we're going to write a simple piece of code that just iterates through our standard library, and what it does is it calls this on our standard library. Now we've added our standard library into this environment. That's all it is. We haven't changed any other piece of code just yet, but we've just added, by sheer adding the anaphoric macro, the anaphoric let, the ability to add this into new environments without clobbering other people's instances. So that's what the first thing that we're going to be doing. But we're not done just yet either. There is a case where we want to be able to debug this environment. And there are several ways of actually attempting to do this, but one of the problems is the fourth interpreter, as it stands right now, is completely closed. It's not open to the outside world to go and inspect. So we need to have some sort of ability to go and inspect just the registers, you know, what's available in the standard library, and so forth. Well, if you may recall that we actually introduced this when we talked about Pandoric macros. So what I'm going to first do is I'm going to actually load our Pandoric macros. And for folks who are watching, I'm just loading just the Pandoric macros. I'm not actually loading the full workshop on macros. So if you look at our GitHub repository, the workshop, the AFP LOL workshop, has all this code. I'm not going to review it here, but I do encourage you to look at that code, and then if you want to, you can copy it over. I just don't believe that, just loading up the script itself would be good enough. So I'm just going to load this at the top of my file. Roswell local project CFP workshop source Pandora. And we'll load that. Oops, I forgot to add one more thing, which is I need to load Serapium. Let's go ahead and do that into my Lisp image. Okay. All right. Load that. So now we have our Pandora macros that we want to leverage. There's two specific ones that we're going to first leverage. One is P lambda. P lambda, the Pandoric lambda, what it does is it creates a closure that is accessible from the outside. And we will be able to leverage it by using the with Pandoric macro. Again, we defined this in the Pandoric macros section. Just to give you a hint of this, I'm just going to briefly open this up just so folks can see what with Pandoric does. Pandoric macros and do P lambda. This is P lambda. What it does is it creates a Pandora. Essentially, it's a let over D lambda. D lambda, if you recall, is a convenience lambda function that we did to allow you to write objects in a very primitive sense without having to and be able to access their particular internals, but through accessors. Yeah, let's go ahead and define here. We're going to replace our new fourth interpreter with just P lambda. Okay, we've now through using Pandoric lambda, we now have opened up the environment for inspection. Let's see how this will work. I'm going to go ahead and define, ideally, this, what is new fourth? This should not give me an error. And what is it? V is undefined. 1 second. Go look at this code. I'm just going to move this guy because we're not going to use it there anyway. So I'm going to take a look here. V is not defined. The B that I used. Oh, right. B is nil right there, isn't it? 1 second.
And just for consistency,
I'm gonna make
your
this.
fourth standard lib add, you want to change that rest to a body.
Ooh, thanks. That should have been a body. Thank you. And this, I'm wondering if I make this into an empty list, that would be problem. Let's see. Let me try pulling the. Something. Yeah, that's what I did. I'm an idiot. I didn't complete the code. Okay, there's one more thing that so this actually, oops, this actually did not need to be changed. That was a red herring. Alright, let's see here. So, what we're going to do is I was mistaken. I had a typo in my code, that I was looking at. So in order to actually support this open environment, we need to not only be able to pass in a lambda, but if you recall, we need to also pass in the state. So what we're going to be looking for here is we're going to actually be looking for not just what the code is, but the actual state of the object that we're actually encapsulating and inspecting around. So fourth registers is our abstract machine that's going to be used by p lambda and the rest of the code to keep track of the state of the machine as we're executing this code. So when this should now work, and I mess up one more thing. What did I do wrong here? Double check. Let for install primitives. Go through and reload the standard library. Then we do p lambda on the fourth registers. Keep track of them, and what did let me try calling v. Why are we calling it? There's no call here. Did I mess up? Let's see. I'm just reviewing what p lambda is doing here. So it creates says this will be the argument that we passed in. Okay. And the body. And p lambda will be indirect get, indirect set. Go look at the errata. Did I mess up something in the errata? There's nothing in the errata there.
Do you have a new fourth by itself somewhere? In earmuffs.
In earmuffs, no, I do not. Why?
Because if you look at line 1 of the backtrace, it's mentioning quote new fourth new fourth. Look at line 1 of the backtrace.
Hold on, it was like a def bar quote new fourth. Let me go look at that. This guy is just the symbol that we're passing in. So what SBCL does is it splits these guys out into separate arguments, and then it calls this top-level form function. So this argument here.
Yes. Okay.
Okay, whoever just tried to talk, it kind of broke up.
No, that's cool.
Okay. All right. Let's see here. Let me make sure that I'm not messing things up here. P lambda is our lambda arguments, so v should not be evaluated there. Then it says it's an undefined function, so I'm wondering if it's this guy. Okay, hold on. I'm gonna do some. I hate doing this, but I'm gonna comment this for the time being. Try executing this. Yep, it was that guy. So why is it doing that? Is the question. It's not undefined. It shouldn't be undefined because it's do list. Let's see here. It should just exit out of it if it's nil. But it's not. Alright. Let's do this. Maybe I did have to keep it like this. V is undefined. Do list V standard library. And call this V. Hold on. I'm gonna just, this is a macro, right? So I could just do this and see what the heck is going on. Okay.
Could you reduce the size of the REPL?
Oh yeah, yeah, sorry. And let me just go ahead and expand this guy. How's that?
Oh, at the top you have set up for standard lib. Can you just go up the top a bit more?
Yeah, sure. Give me a second here. Let me just do that. And hold on.
Alright, wait. Go back down again. Alright, that's cool.
Okay. there's something here that I'm not entirely sure where it's causing some but I bet you there's a couple things that we need to also finish implementing before we can actually go through this. Let's go ahead and finish off the primitive forms to load up the standard primitives. And at least if we have that installation, I think the code should work. Let me see here. Hold on. I see what the problem is. Probably, hold on.
Question.
Yeah, I'm listening.
In that def macro, fourth standard lib add,
Yeah.
the last line, should that single quote be a back quote?
You know, I wasn't sure about that. That might be a back quote, but I'm pretty sure it's a single quote. It's a quote lambda.
It's a single quote in the book, but I'm just wondering if that should be a back quote.
I don't think it's a nested back quote. I don't think we should have two back quotes there. That specific single quote comma is a I'm forgetting what it was. It's not splicing. It's I actually have it written down somewhere. Give me a second. It was I think it's in my LOL workshop notes. Give me this. This is I bothered. Let me just go and double check on that. See, he mentions it actually in chapter 3. It was. Right. So what quote comma does is so comma has just takes it out of the unevaluated mode, allows that form to be injected as is. So it doesn't it unquotes it, so to speak. And what that quote does is it just makes it into a list, if there is one. So in that at body, if you that ampersand body, if you notice that it's like rest, it will take in all the forms and then stick them into a single list. The comma will splice in rather than try to do what comma at does, which is puts them in one at a time. It just takes the entire list and unquotes it and injects it in there. And that quote, what it does is it just makes sure that it's treated like a proper list rather than a Lisp expression, an S expression, where the first argument is an operator. So if we didn't have that quote there, it actually will throw up even more. This guy will basically, if we have this or this, it's the same effect in this particular case.
Okay.
It's how splicing works. Splicing has some very special like kind of rules for comma at quote comma at. There's like 3 or 4 different combinations. Unfortunately, I can't find the exact notes where I presented this right now. But what I'll do is for folks who are interested, I will post those notes as part of my comments for this before I check this guy into GitHub. But I don't think that that's what's causing this issue because we haven't actually invoked Fort Standard Library Add just yet. So let's see here. Where was I? I was not this. Not this. I'm wondering if I have to do this. I shouldn't have to, but because we haven't actually leveraged this just yet. So let me just try something here. Undefined is coming from something in the expansion. So what is it actually expanding to that's causing a function call? Fourth lookup v dictionary. No, I bet you it's because it's trying to evaluate v in the dictionary. Here we go. Do I need to quote that guy? Maybe he quoted it. I just missed it. Nope, he did not. That is wild. Actually, hold on. I did finish that expansion. It was like this itself, then create set on the body.
Did you try killing the image and start recompiling everything?
That's a good idea. I'm gonna probably try that now. Start. And here, argument. Hold on. Where in my code is it actually complaining? Oh, here it is. Fourth register is unbound. Go and look at that. In package. The hell do you mean fourth register is unbound?
It's in a comment. Def fourth registers, middle of the line. Sorry, middle of the buffer, left hand side.
Yeah, right here, right? So it's on line 18. No, I see it. It says that it's unbound though. So it's like, why is that unbound? Doesn't make any sense. Because it's clearly bound, as you can see right there. it's there. So I'm wondering if it's not liking the way I'm doing this. Let me do this. I'll load this later, right when I need it, which is right around here. Okay, let me go ahead and restart my image because I don't like. Okay. Still says fourth register's unbound. So what is it that it's complaining about? I'm trying to see if I had a typo there and I just didn't catch it. Okay, for the time being, let me just do this for a second. Let me go ahead and restart Lisp again. And still says it's unbound. So it's clearly not that one. we shouldn't be using this anyway. And this one is being redefined later on anyway. Variable new fourth is unbound. That's slightly better. Okay. Here is new fourth. New fourth. Ah, this guy. We haven't actually implemented that piece yet. That shouldn't be there. Oops. And the Serapium. Okay, so let me go ahead and add one thing into my ASD file. Since we're going to be using our Pandoric macros, I may as well add this as a dependency. I'm only adding Serapium, folks, because we're using it in our Pandoric macros, and they use it for some of their conveniences. Okay, so now let's go here. Okay, that's better. And we're back to where we started. All right. Undefined function v. That is just so odd. There's no function v in this code. There's a problem in our macro expansion. That's what that means. So, going back to this. Hold on 1 second. Let's see what the actual. I'm just trying to see what the error was here. Doesn't actually say. Oh, and then it's undefined. I'm structuring the code so that the things are getting defined in the appropriate place when it compiles, since we kind of moved some stuff around. Actually, this should be a def parameter, not a def var. Now that I think about it, because we're passing in an initial value, def var has it on optional.
Question.
Yeah, sure.
Where is new fourth interpreter? Okay.
This is right there.
It's saying that during macro expansion of new fourth interpreter, fourth registers is not defined.
Right. And that's kind of odd, since it's already been defined up here on line 18. So let's see, Control S. Sorry. Control S. That's what. I mean, there. And it's there. You can see that it's there. No, I did this the other day. It needs to be there.
Okay, in the macro new fourth interpreter, fourth registers is used twice, right?
That is correct.
Can you rename those into fourth registers 1, fourth registers 2, and then set up a new def parameter of those two above so we can know which one is causing the problems?
Sure. Let me do this. I'll grab this guy. And all these, although these should be the same variable, and let me just go ahead and restart my Lisp. Okay, it's all polluted right now. And fourth registers 1 is unbound. Aha! Good call, Richie. Good call. Well, question is why? See, if we compile it as is, it's fine.
Could you do a macro expand that alet line?
Yeah. We want to macro expand this line?
No, in the def macro new fourth interpreter, the first one where it says alet.
Oh, got it.
Yeah.
That one. You know what? Let me try using the indirection version, because the book actually suggested to originally use the indirect version. There might be a bug in the ALET. You're right. Let me do this. Let me change this back. And what I'll do is I'll grab my copy of the ALET percent sign, which is indirect chaining ALET. There isn't much in terms of code difference, you will see. So the only difference between this is a closure that's executing the last evaluated expression, and this is just returning it. It shouldn't change much, but it does eliminate some of the indirection that we're seeing. Go ahead and get rid of these guys and see if that does anything. Fourth registers is still unbound. Okay. Control C. Oh, sorry. Let's do this. Oh. Sorry, I'm messing it up. Let's do this, and then here, let me look at So I'll deal with that. That looks like some weird def parameter setting that I'm messing with. That's separate from this interpreter, because once, as you can see, once I compile this and load it into the image myself, everything is peachy keen on this side.
Okay, one question before you go. Oh, move on. In a regular let, right?
Yeah.
You normally have two. All the what's being defined is within two sets of parentheses, right?
That's correct.
So in this ALET, does there need to be any, not in the macro, but in the actual call?
Yeah.
Does the variable that's being under ALETed or whatever need to be within parens?
If I understood you correctly, the answer is no. The reason is what ALET is actually doing is two things. One, it is taking...
Question. If you look on page 163,
page 163,
yeah. He defines ALET on page 162, right?
Yeah. Mm-hmm.
And on page 163, gives an example where he's calling ALET, and whatever, basically, ALET is replacing a regular let. So whatever he's defining is within 2 sets of parentheses.
Oh, okay, I see. You're talking about the usage.
Yeah.
Yeah. So let me go and look at this macro expansion. Maybe that's the key. Okay. I see now what you're trying to get at. So looks like there's a bug in this code that he wrote. Because if you look on page 298, or even later on, the ALET is passing fourth registers directly. But the way we defined fourth registers, where is it? It was in page 287. I just switched it between def var and def parameter. It doesn't make a big deal here because of the optionality of the arguments in def var versus the requirement that it be initialized. He's defining it as a strict list, which is why, as you can see right here in this code, when it expands, you're getting the list as it is. The fourth register is being unbound argument leads me, I'm wondering. Maybe I have to do that. I don't think I should, but maybe. Let's see. We can see. We can try this out. So here, I'll make sure I got smart friends turned on. Okay. Let's see that, and this will be no, this will cause issues because if I do that, I have to somehow splice each of the arguments and make them into their own parameter. That should have been done by this guy right here. So if you look at ALET as it stands, what it's doing is it's taking your list and it's splicing it. We could try that. We could see.
So is this failing just on the compilation of def macro? Of this macro?
The macro compilation doesn't fail. It's the evaluation. Yeah, that's what I thought it would do. So this guy is saying that it's undefined, but I don't see anywhere where we're doing a fun call on that argument as a function. The only thing I could think of is this guy right here. When we're doing the fourth lookup, it is for some reason treating this guy as a function call rather than as a word, like a quoted word. Let me see if that's the issue. Okay.
In the fun call above.
Actually, you know what?
The fun call.
Yeah. Right here.
Yeah. How does that work?
It's taking v and it's passing v as an argument to this.
To this.
But
okay.
But you know what? Let me try something here. I think we commented this out before, but I wasn't sure if this is.
There's no errors when that's commented.
We still get the error about the v though, which means that it's this guy right here that is causing. Oops. Sorry. Let me do this. Yeah, that's what I want to do. So we pull that guy out. In p lambda. Maybe I messed up in my Pandora, in my p lambda. Well, it shouldn't be because we've used this before in multiple cases.
Does that v need to be within parens after the call to p lambda?
Yes, that's a list of arguments in the for the lexical environment. So if you look at this right here, what is p lambda doing? It actually it creates it takes all the parameter arguments and converts them into a list. Okay, into separate lists.
I'm just wondering because that v within that's a function call, isn't it?
No, by itself it's not a function call. That v, okay, that has is passed here. If you look at the first argument, p lambda v, it's passed into creating a lambda for the local closure. It takes the body of the function that we pass in later on, which is the let binding there that does the lookup, and it creates a local function for this. You see that there? And let's see here. Pandoric set and Pandoric get.
Okay, question. If you try removing instead of it being used as a p lambda, just call it as a regular lambda, you still get the same error.
Okay. We shouldn't, but I mean, we're gonna get we'll have a different issue with the regular lambda. The issue with the regular lambda is the fact that every time we call, we're gonna still reevaluate everything. Yeah. This is what I was expecting it to complain about, because this is saying that this macro and these two aren't available. I think we'll stick with this for the time being, but really we need to use the Pandoric lambda. Otherwise, we're not going to be able to inspect the environment when we want to debug. So I'll just use this for now. I mean, that's fine. Let's see here. So as you can see right here, forth install primitives is not yet defined, and that is something that is necessary. Before we do that, though, we also need one more thing in our current version, minus the fact that we can't do Pandoric Lambda right now, and that is we need to talk about the one of the additional abstract remaining abstract registers we have not yet talked about, which is the D-table abstract register. What is that? Well, the D-table abstract register is nothing more than a pointer to a hash table that will keep track of some information that will be used later on when we start going into installing our primitives, which is what we're going to be defining next. So this guy is just right now going to be initialized here. That's it. So now we have our D table that's going to be used for keeping track of specifically the thread or the code block that we're currently compiling on. To start with, there is one thing that was mentioned in the book that I want to mention here. And again, this is a stylistic guideline that the author put in that I'm mentioning it here so that when you're reading other common Lisp code, you'll be wondering why there's a difference in the way he did things. So we've talked about earmuffs in the past, and we've talked about the importance of making that useful for user experience, because it's useful to know by looking at earmuffs if something is a dynamic variable or a special variable or a lexical variable using a let binding. Well, the author strongly believes that such thing is pointless, but it's pretty useful from a stylistic standpoint. Additional example that he brings up is sharp quoting your lambda your forms is a bad idea because it means there's more modifications that you need when you want to change to a different lambda form, like if you want to use an anaphoric lambda or a Pandoric lambda and so forth. For some reason, he's strongly against that, and he brings up the fact that this Let Over Lambda has a book has promoted closure-oriented programming rather than using features of class, which we've talked about in a bit. So let's get started on the next piece of code that we have to implement. So far, we've implemented our skeleton for our interpreter, but we can't really do much, as you can clearly tell. We can't actually go and try some of the examples of things that are there. And until we do so, we won't be able to run new fourth interpreter. So let's actually go ahead and implement these final three functions, so we can actually at least have a working initial version of what's there. The first thing is fourth install primitives. This is a macro that nothing more than its responsibility is to essentially set up our standard library and hook it into something that we could then leverage in the initialization code. In fact, before I forget, let me uncomment this guy. And recompile this and make Sure, we're still good. Yeah, we're still good. All right. So what is this guy doing for this? Well, again, this is going to be a prog-n because we need to run this somewhat sequentially. We need to first generate our dictionary. Okay, so how do we do this? We're just going to go ahead and run a map on the following lambda function. This is kind of a weird lambda function that they've written, so I'm not entirely sure how this works. We'll review this in a minute. Let me first type in the code and then we'll go through it. And, let lambda
By the way, what's the GitHub repo?
For the fourth demo, that has not yet been set up.
No, just a regular one. So look for the Pandoric macros list file.
Oh, that is in the AFP ALL workshop. So I'll send it to you. Give me a second. It was in Atlanta FP. Make sure that all my stuff is in there. Yes. All right. All right. There we go. Where are you? And for folks who want to have this, I'll go ahead and post this onto the into the YouTube description.
Thanks.
No problem. Okay, I'll go back to where it was. So we then set up the dictionary, make word. And this is obviously going to require us to define a couple of other things. It's going to be obviously car of the current name, previous node is going to be the dictionary itself. Whether or not it's immediate is going to be obviously the that. And this is our thread flag. What that is, and then we set F. Oh, I don't need to freaking do that. Folks who are watching right now, you may be wondering why I'm not going ahead and creating a. The hell? That's really odd. Unbalance parentheses. may be wondering why I'm not making, and those who are following the book specifically, you may be wondering why I'm not using two separate setups here. One of the nice things about generalized setters like setf is that you could write multiple assignments in the single setf. And that's kind of useful, especially when it makes some of the code look a little more clearer with respect to intent, rather than having those all over the place. Just getting into that habit of not using multiple setups might be a good practice to get into. It's been taking me a while to actually get to that point. So, alright. And then fourth primitive forms. This is on our fourth primitive forms.
Okay, just an FYI.
Yeah.
The code that you have for your Pandoric macros.lisp, right, follows exactly what's in the book, right? He mentions in the errata that there's a problem with Pandoric let-set.
I thought I had corrected that, because I looked at the production code in there.
Yeah. So if you look at the production code for Pandoric let-set, you'll see in the T part he only has one set of args as opposed to two.
I have actually saw that. I saw that this morning. I corrected it locally, but I have not checked it in. I will push that.
Okay, I'm just wondering if that because
in fact,
P lambda uses Pandoric let-set. So I'm just wondering if that could be causing the incorrect errors, which, yeah.
So no, I agree with you, and that I thought so too. But I remember that I fixed that this morning. As you can clearly see here, this is using one variable instead of two. If you see my screen, my Emacs buffer.
Yeah. Okay, I'm just wondering.
Yeah, no, not a problem. That's a very good question. I thought so too, but I thought I fixed that, and I was like, wait a second, I thought this is already done. So I corrected it. All right. So what was I? This guy needs to be actually primitive forms, just to make sure. SWWW. Yeah, that's right. All right. So what is this function doing? This function is actually generating from our primitive forms, our global list of primitive forms, as you can see here. We added them here earlier. If you look at through our defined fourth primitive, we've defined all these primitives into this fourth primitive forms list. And what we're doing now is we are actually going through each of that list, and we are generating our standard library. So that's all what this guy is doing, as you can see right here. But comma, not inside back quote. Which one is up? Back quote prog line. 186.
Under immediate, colon immediate.
Ah, right here. Thank you. This guy, let me see, did I mess up something here? Oh. Got it. This needs to be that. New dispatch function. What? This is weird. Hold on a second. Okay. This guy here should be a macro. This is correct in terms of what it should be. But I'm wondering what is causing this guy from not recognizing that it's been spliced. Maybe I have to do something like this. No, that won't work. What's even odder is this guy isn't actually a proper lambda. It's accessing A1 from the outside, but it's not actually.
Question: have you upgraded to Catalina yet?
I have.
Okay, no worries then.
I've upgraded to Catalina for quite. I've been in Catalina for quite some time now.
Okay, I was just going to suggest, just in case this might be an SBCL-ism, to try Allegro Lisp, but since you have a Catalina, that's not going to work.
Yeah.
What about CCL? Just to see?
That's a good question. Okay, we could try this. May not necessarily be able to try it here, but we could. Do I have CCL? Let's see. Let me just clear it up. not sayonara, it's something else. It's, what was it? Control C meta X. There's a way to actually start another REPL for a different Lisp, but I'm forgetting.
I think it's you have to do Control U before calling slide. I think.
Control U.
Then meta X.
Slide. There we go. That's it. What? I'm going to my Emacs directory here. Did I forget to provide? Oh, it's there. Starting. Maybe it's this. Fly mREPL new. No, that's not it. Here we go. I can provide multiple Lisps. That's not a problem, but how do I? Yeah. What you said, it's just that I provided the wrong argument. What? Did I not use this originally? Should be using loss. Fly Lisp implementation. Do I not have CCL installed? Got it. One. Yeah. Unfortunately, the version of Clojure Common Lisp that I have, at least from Roswell, is throwing up a kernel panic, and I'm not entirely sure why. I have to go and I was hoping that there was an issue that
It depends on the version, because there was a problem with one of the CCL versions.
I think it was 1.11.5 is what that I have. It sounds like they may have upgraded it, but I haven't downloaded the latest in a while. I haven't tried to see if CCL bin was updated, but I will try that.
No.
Yeah. It's heading on 2 o'clock. I think we're gonna let's continue this. I'm gonna say next Sunday, just to keep this going. Would you be interested? Same time. Perfect. Okay.
Question: Do you have LispWorks installed?
I do not. I was
712.
I should get ListWorks free. I think is there, isn't there? Like a free one that you could try out.
The new version available for Catalina was released on Thursday, and they upgraded from Personal 6.1 to 7.1.2. So I just have them just in case, because this might be an SBCL-ism, where it's throwing up this type of error, whereas it might not necessarily generate that error in a more traditional Lisp, which is like Allegro Lisp or LispWorks.
Right. I was going to try Allegro, but I haven't downloaded the latest version yet. Just because
there is no Allegro for Catalina. Only LispWorks.
Yeah, but Allegro works on Linux, right? So
I
was going to check this. I was going to check this in and then try it on my Linux box.
Sorry, I meant Allegro, the Personal Edition, or the Express Edition, isn't available, which is the free one. Doesn't exist for 64-bit on Allegro.
Oh, really? That I did not know.
Okay. So only LispWorks will work on 64-bit, I believe.
Since Personal Edition for LispWorks is still 32-bit, at least according to...
The LispWorks one got released on Thursday.
Here we go.
Rainer put a thing out on Reddit.
Oh, nice. Okay. I have to read the release notes.
If you're not on the hug list.
Okay. I will take a look at it and see what's going on there. But ideally, I'd like it to work on SBCL, so I don't give folks, I hope it's not an SBCL-ism. Otherwise, I would have to update my SBCL. I don't know what version I have right now. What? The SBCL-bin. Yeah. All right. That's it for today. I'm going to go ahead and check this guy in. I'm going to really fix this P Lambda stuff so that we can get the ball rolling next week on this, because we're having too many weird issues here following some of the examples in the book, and I'd rather give you guys some chance to ask questions rather than have you guys see me like twiddle around with weirdness between what's in the code and what's in my Lisp REPL. Are there questions from those that are watching the stream right now? Okay. Thanks, Richie, for staying late. I know it's kind of late for you over there. I appreciate it. I'll see you next week, next Sunday on this. Reminder for folks watching this, we still have our Saturday study group. Hoping we will go back to the FLAC demo to finish off some of that for you guys. But we're still working on this guy on Sundays now, from 11:30 to 1. I will post it out on Meetup so folks can have the chance to bookmark the Hangouts.
Don't forget to correct time zone.
Yes, I will. Oh yeah, 1:30 EDT, 11:30 MDT, and then I will put in even the GMT time so folks can actually mark it on their calendars. I'm sorry that Meetup for some reason doesn't do some of that weirdness. I would hope that it would, but I haven't noticed that it didn't give me a way of putting like a GMT time and then have everyone get the appropriate time zone. That would be kind of nice. But yeah, I will see you guys next week.